Hello everyone. In the previous videos we have learnt about the area and perimeter of a sector of a circle and also the area of segment of a circle. In this video we are going to learn about the combination of plane figures. In that combination there may be a square, a rectangle, a triangle, a circle, some part of a circle that is a sector or segment. This type of figures we are generally finding in the designs of the table cover, on the wall somewhere, in the flower pots and so on. If we find the area of some portion of that particular figure, then we have to apply the concept of the area of circle, area of the plane figures like rectangle, square, etc. or triangle, and also the area of or perimeter of sector and the segment. What type of problems we may have, we will discuss some of the problems in this video. The first example we are taking here is, in the given figure, a square of diagonal 8 cm is inscribed in a circle. We have to find the area of the shaded portion. We know that if a square is inscribed in a circle, because every angle of that is 90 degree, it means every portion of this will be making a semicircle or not, and then we can say the diagonal will be the diameter. So we can say for the solution that the diagonal of square is equal to the diameter of circle, that is equal to 8 cm. It means the radius of circle will be 8 by 2, that is 4 cm or not. And to find out the area of the shaded region, what we should do? We can find out the area of the circle first and then the area of the square and subtract them. So if we subtract the area of the square from the area of the circle, the area of the shaded region will be obtained. Area of circle here is area of circle is pi r square, as we know. That is equal to 22 by 7 into 4 square. Or we can say 22 into 16 upon 7. Equal to 16 into 22 is 352 upon 7 centimeters square. The area of square. In case we know the diagonal, the area of square can be taken as the area of a rhombus. That is half into diagonal. Here it may be half into diagonal square because the diagonals of a square are equal. This is equal to half into 8 square. That is 64 by 2, or you can say 32 centimeters square. Therefore, the area of shaded region is equal to area of circle minus area of square. That is equal to 352 upon 7, that is the area of the circle, minus 32, that is the area of the square. If we take the LCM 7, this will be 352 minus 7 to the 14, 7 to the 21, 2 to 4. And if we subtract that, it will be 128 upon 7 centimeters square. This is the area of the region. The second example we discuss here is, find the area of the shaded region if the radii of the two concentric circles are 14 centimeter and 7 centimeters respectively, and angle AOC is equal to 40 degree. What we find here to find the solution of it, that this shaded region is the portion covered between the two sectors. The center of the circles is same because they are concentric circles. And the radii of them are 14 centimeter and 7 centimeter. This is 14 centimeter, this is 7 centimeter. We can write the radius of the large circle to be 14 and we write it as R1. Here R1 is equal to 14 centimeter. The radius of the smaller circle we take as 7 and that we can consider as R2. R2 is equal to 7 centimeter. The angle of sectors, both the sectors is the same, that is 40 degree. So we can write here angle of sector is equal to 40 degree, that is theta we consider. We know the formula for area of sector. Area of sector is equal to pi r square into theta upon 360 degree, that we know. The area of shaded region can be obtained by either finding the area of the sectors separately and then subtracting, or directly we can subtract them together. So we can write here the area of shaded region is equal to area of sector OAC minus area of sector ODE. We can write this as pi r1 square into theta upon 360 minus pi r2 square into theta upon 360. If we take pi into theta upon 360 is common, we will be getting here r1 square minus r2 square. Substituting the values here, we get 22 by 7 into 40 upon 360 into 14 square minus 7 square. 40 cancels this 9 times. So we are getting here 22 upon 7 9 is 63 into 14 plus 7 into 14 minus 7, a square minus b square is equal to a plus b into a minus b. This is the way to make the calculation easy. So we get here 22 upon 63 into 21 into 7. 21 cancels this 3 times. 22 into 7 is 154 upon 3. So 154 upon 3 centimeters square is the area of the shaded region. The next problem is, from the vertices of a triangle PQR, the circular regions of radius 14 centimeters have been cut. Find the area of the 3 circular regions. For the particular problem, first we draw a triangle PQR and draw the arcs of radius 14 centimeter from each vertex and shade these 3 regions, because we have to find out the area of these 3. We find that for all these 3, these are the 3 sectors, but the angles, they are different. There is P, this is Q and this is R. So here we find that the radius R has been given as 14 centimeter from each. The angles of the sectors are P, Q and R. And we know that area of a sector is given by pi r square into theta upon 360 degree. So we can find out the area of all these 3 sectors together, because the radii of each part is same. So we can write the area of all 3 sectors is equal to pi into r square into p upon 360 plus pi into r square into q upon 360 plus pi into r square into r upon 360. We are getting here pi r square upon 360 as common. So we are getting here p plus q plus r. We know for a triangle, angle P plus angle Q plus angle R is equal to 180 degree. That is the angle sum property of triangle. We can write here angle sum property of triangle. So we can substitute here P plus Q plus R as 180 and substitute the value of R. This will give us pi into R means 14 square upon 360 into 180. 180 cancels this twice and we substitute the value of pi, that is 22 by 7 into 14 into 14 into 1 by 2. 7 cancels this twice and this 2 cancels this 2. So this comes as 22 into 14. 22 into 14 is 308. It means the total area of all these three sectors is 308 centimeters square. Sometimes you may be asked to find out the remaining area of the triangle or the area of the remaining part of the triangle. Then what we will do? We can find out the area of the triangle and then subtract the area of all these three sectors from that to find this area. One more problem we discuss here, that is in figure AB and PQ are two perpendicular diameters of a circle with center O and the diameter AB is 14 centimeter. We have to find the area of the shaded region. So what we have here, AB is the diameter of the larger circle and that is 14 centimeter. Can we say that radius R1 of the larger circle will be 14 by 2, that is 7 centimeter. It means we can say that OA is equal to 7 centimeter and this is equal to the diameter of smaller circle. It means what is the radius of this? Therefore, the radius of smaller circle, that is suppose R2 will be equal to 7 by 2 centimeter. The total shaded region is, as I told you, having two segments and one smaller circle. The area of these two segments can be found out by using the angle 90 degree. The area of this segment into 2 will give you the area of this complete region. We can also use one of the method, that is that if we find the area of this semicircle and subtract the area of this triangle, that will also give us the area of this particular region. First we find the area of the smaller circle. Area of smaller circle is pi r2 square, that is 22 by 7 into 7 by 2 into 7 by 2. This 7 cancels this, 2 cancels this 11 times, thus comes as 77 by 2 centimeters square, or we can say 38.5 centimeters square. Now we can find out the area of the shaded region PBQ. Area of shaded region PBQ, that can be taken as area of semicircle minus area of triangle PQB, or not? Area of semicircle, that is half into pi into r1 square, because this is the semicircle from the large circle, minus half into base, that is PQ. into the altitude, that is OB. Because we know area of triangle is given by half into base into height or altitude. If we apply the values here, this is half into 22/7 into R1 is 7 into 7 into 7 minus half into, what is PQ? PQ is 14, that is diameter of the circle, into OB. OB is the radius, that is 7. 7 cancels 7 here, 2 cancels this 11 times, that is 77. Minus 2 cancels this 7 times and this is 49. So this is 28 centimeters square. So what is the area of the total shaded region? Therefore, area of total shaded region will be equal to area of the circle, smaller circle, plus this area, that will be 38.5 plus 28, or we can say it is 66.5 centimeters square. So with these examples, we have understood how to find out the area of the plane figures which are containing the circles, the part of circles, and some of the plane figures. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.